Hey everybody, my name is John Vale, and I will be speaking today on disruptive tolerant networks. The Delay Tolerant Networking Research Group was chartered as part of the Internet Research Task Force, or the IRTF. The Delay Tolerant Network is another term for disruptive tolerant network, and there's a couple different groups that are working on a similar type protocol, and it's all known as DTN, but some call it delay tolerant, some call it disruptive tolerant. The purpose of this research group was to find a way to communicate through highly diverse networks, even if there is no end-to-end connectivity. And uses for this include underwater, military, tactical, spacecraft, or for use in developing parts of the world. NASA's been looking at this pretty hard because, for instance, messages being transmitted to the Mars rover take between 5 and 20 minutes, depending upon where we and Mars are in their relative paths around the sun. So you can see why a protocol that would tolerate major delays would be useful for them. DARPA is also working on this, and they're building on the work previously performed by the Internet Engineering Task Force Delay Tolerant Networking Research Program. And what they do is provide delay tolerance by organizing information flow into something called bundles. And these bundles are to be routed through an intelligent network. The messages will pass through the network with successive responsibilities rather than the traditional end-to-end scheme that we normally use now, what we're used to with the internet. So the DTN basics are that endpoints aren't always continuously connected. They use a stored and forward approach. So each node will keep the information as long as it takes until they can safely hand it off to the next node. And it doesn't necessarily mean that the DTN nodes require a large storage capacity in order to maintain end-to-end data integrity. So RFCs 4838 and 5050 were established in 2007. They define a common abstraction of software running on disruptive networks, which is commonly known as the bundle protocol. So this bundle protocol contains enough semantic information to allow the application to make progress. They can travel across varied network topologies, including both IP and non-IP based transports. The transport layers carrying the bundles across their networks are called bundle convergence layers. This bundle architecture operates as an overlay network. So basically here we use it terrestrially. It would sit on top of the internet. And they use endpoint identifiers, or EIDs. They also use application level preferences. There are 6 classes of service, one of which is priority of delivery, which include bulk, normal, and expedited. Another class of service is authentication. And part of this protocol is that security is a major focus. So most security methods mutually authenticate user identities and message integrity. But with DTN, the DTN routers and gateways are authenticated to each other along with sender information by the forwarding nodes. And this conserves network resources by preventing traffic at the earliest opportunity. The original solutions from the delay-tolerant research community include the use of identity-based encryption, which allows nodes to receive information encrypted with their public identifier, and the use of tamper-evident tables with the gossiping protocol. Now this has actually been tested. BBN Technologies has simulated a 20-node DTN with each node only being available 20% of the time. But they were able to deliver 100% of the transmitted packets, which is pretty amazing. The University of Massachusetts Amherst has something called DieselNet, where what they did was they hooked up the school buses. There are 40 UMass buses that used off-the-shelf single-board computers, GPS receivers, and radios. And they mounted these in the buses, and as the buses were traveling their routes, the DTN nodes were querying each other to find out which nodes saw each other frequently. So when they had a message to transmit, if the node that they were querying was related to the final destination that the message was going to, then that message was handed on. This was pretty amazing that they actually put this on buses, had the buses driving around, and just use the local Wi-Fi as the buses got within range of each other to hand these messages off. And then eventually there were buses that would get within range of a wired and then hand off the message from there. And it was very successful. And like I said, it's pretty amazing that this was able to happen. They've actually made this work. So here are my references. I hope you've enjoyed my presentation today. It was something I found very interesting, and I hope that you did too. Thank you for watching.